Hello there, and welcome to another fantastic video recorded from my donut, otherwise known as my laptop, which is very out of date. And, the microphone has issues. So, anyways, let's get started. Well, today, we're gonna do some quadratic equations. Uh, you know what, I'm not gonna write it down. I'm running out of ink. Once again, not out of ink. I apologize. I'm running out of. Well, this marker is just becoming very dry. So I'm gonna try going back to my original marker from my first video my first mathematics video. Anyways, so quadratic equation. What exactly is a quadratic equation? Well, a quadratic equation, QE, has the form of A, where A is just some random constant. It could be 1, 2, 3, 4, 30, blah, blah, blah. It could be any number. A could be any number. Times x squared plus B. Once again, B is like A and can be any number. Times x. A and B are both constants, plus C. And, I guess you guys can guess from this that C is just also going to be another constant. So that is the form of a quadratic equation. Well, yeah, ax squared plus bx plus c equals basically, some number, usually it won't equal some number because it'll end up being 0. Because, you have a constant on the other side, and you just subtract the constant from both sides, and you still end up getting some constant. Anyways, let's work through an example of a quadratic equation here. So, in my book here, I have the equation x squared equals 12 minus x. Now, in this function, we want to solve, well, actually, it doesn't even ask to solve for x. It just says, basically, take this equation, x squared equals 12 minus x, and put it into a quadratic form. So using our little helpful tool of the structure of the quadratic formula, ax squared plus bx plus c equals 0, we know that we need to get 0 on one side of the equation or the other. So I see a minus x here. And whenever I see a minus, a negative variable, I kind of want to add it to the other side to make it positive. So let's add x to both sides of this equation. So we end up getting x squared plus x equals 12, and minus x plus x just ends up becoming 0. What am I changing this equation? No, because I'm adding the same things to both sides of the equality. So we end up getting x squared plus x equals 12. Well, what does that imply? It basically implies that, well, we're getting closer and closer to the format of the quadratic equation, and we could solve for x at this point, but, it's higher algebra, so let's not do that. It just basically means that we can take this a step further. It's a x squared plus x, and we want to subtract 12 from both sides so that we end up with 0 on one side of the equation, so that we end up getting our quadratic form. So the answer for our original equation, which was x squared minus 12x, or x squared equals 12 minus x, the answer to how do we put this into a quadratic equation ends up becoming x squared plus x minus 12 equals 0. And you know what? The book doesn't say, solve this quadratic equation, but I'm going to do it anyways. There are two ways to solve a quadratic equation. Either you can do the quadratic formula, which is minus b plus minus the square root of, b squared minus 4ac, all divided by 2a. But in this case, it looks like factoring is an option. So, basically, we notice that we somehow need to get x squared plus x minus 12 into a form of x plus some constant a times x minus some constant b equals 0. Now, I'm not going to go over, how to solve for A and how to solve for B, but, I'm just going to say x plus 4 times x minus 3 will give us this equation here. And if you basically use the mathematical distribution property, you get x squared minus 3x plus 4x minus 12 equals 0. And you combine those terms together. Let's just run through this. So x squared minus 3x plus 4x minus 12 equals 0. And we see that minus 3x and plus 4x, we can combine both those things together to get plus x, and we see that we end up getting the same quadratic formula from above, except in this case we're factoring it, or we're putting it in the factored form so that we can solve for x explicitly. In this case, what value of x plus 4, well, we want to say that we want to make this equation 0. So x plus 4, if that's 0, then we definitely know that if you multiply 0 times x minus 3, you just get 0. And vice versa with the x minus 3. So what values of x will make the first bracket, x plus 4, 0? Well, that's pretty simple. You think about it. What's minus 4 plus 4? That just ends up becoming 0. So x is minus 4. Yeah, hold on. Dying pen here. Marker. You know what? I need to start watching some English tutorial videos. I apparently don't know what I'm talking about here. Anyways, when it comes to objects. So, x minus 3, what makes that thing 0? Well, 3 minus 3, that's 0. Anything else won't work. You need 3 to make that 0. So we end up getting x equals minus 4 and x equals 3 in order for these statements to be true. In order to make this equation, or set it to 0. So we just solve for x in this quadratic formula here. And once again, the dot triad here just doesn't mean the Legend of Zelda or the Ocarina of Time or, Wind Waker or whatever. It just means therefore. Therefore we can conclude that through solving this quadratic equation, x equals minus 4 and 3. Well, hope to see you guys in the next video. Well, hopefully we'll do some cool stuff. And this donut thing will, you know what, I'm just going to say, stay tuned, look for the next video, find out what happens. Do I end up getting a new marker? Will I ever get a decent camera? Or will I keep using the same donut and the same dyeing markers for all eternity? Stay tuned. I'll see you guys. Well, actually, no, I won't see you guys because you're via internet. But anyways, stay tuned. Oops.